All right, welcome everybody to Dave Cooper Live, where each week we are bringing you the people, the products, and the process that will help you build it better. And of course, this week, I am super excited to welcome our guest because we will discuss many of our favorite topics like carbon reduction, like building efficiency, like the circular economy, and so much more. So today we welcome Bay Area startup Urban Machine, who literally just came out of stealth mode with a 5.6 million seed round. Eric Law, co-founder and CEO of Urban Machine, joins us and shares how they use AI and robotics to address the 37 million tons of wood waste in the U.S. each year and clean it for reuse as a premium lumber. Urban Machine was founded by Eric along with CTO Andrew Gillies and lead software engineer Alex Thiele, and now it's time to meet the machine that turns wood waste into an opportunity. But first, we can't do any of this without our sponsors. So a big shout out to Forward Solutions Group for allowing us to deliver all of these examples of construction innovation. Learn more about Forward's recent acquisition about Moducore, an ERP solution for offsite manufacturing. Contact Ben Hershey at ben@forwardsolutionsgroup.com. And we can't do it without our good friends from Howick Ltd, who have a long history of innovation in cold form steel manufacturing and produces innovative precision roll forming technology for customers throughout the U.S. and the world. Check out their Machines Buyer's Guide for offsite modular construction or fast build construction with light steel for framing. Visit them at howickltd.com. All right, without further ado, let's hop into it and bring Eric onto the show. Eric, how are you, my friend?
Doing great. Thanks for having me, Dave.
Hey, this is awesome, Eric. This is something that we've needed to talk about for a long time in this industry. And you were the actual person and some of the other co-founders that woke up one day and said, well, we can do this. Why are we not doing this? It doesn't make any sense that we're not doing this. So I am so excited to talk about Urban Machine and what you guys are doing. But first, we want to know everything about you from the moment you were born to this very moment in time. Don't leave out any good stuff from the hospital, or we will have your mother on our show. And believe you know, Eric, it has happened, and it can get quite embarrassing for you. So just an FYI there. But go ahead. You got 2 minutes. Let us know a little bit about who you are.
Yeah, so I've got about a 20-year career in construction and technology. Graduated from Cal Poly San Luis Obispo, mechanical engineer, went into construction industry, working for Kiewit for a while, and then bounced back and forth between construction and technology. Everything from contractors to started a SaaS company and sold it to Bentley Systems back in 2015. I love construction. You get to build stuff. It's just a great industry, a lot of great people you get to work with. And then I love technology as well. And
Yeah.
so we get to combine the two in this opportunity.
Right. Yeah, you do. And you get to help a whole lot of people out. You get to help the environment out. You get to leave the world a better place. So listen, how did this all come about, right? And then we're going to get into the machine. Like, who just wakes up one day and says, I have an idea. I'm going to build a robot. I know a guy that might know how to do this. And we're going to build something that can take reclaimed wood, demolition wood, run it through a machine. It's going to remove the nails, going to remove the metal. And by the way, you can reuse the wood right away, immediately on your job site if you want to. And that's kind of the vision of where this is headed. Who does that, Eric?
I'm one in a billion, I guess, a pretty short list of us. I was doing innovation at Swinnerton. I built the innovation program there for about 3 years to build that group up. And there we focused on bringing robotics into construction, right? How do we fix the labor shortage? Because we weren't going to find more people to build. And so our program was focused on robotics. I got involved with the sustainability initiative where we're looking at our waste streams coming off of job sites. And concrete and steel both have recycle paths. And what we found with wood is there was no path. It just went straight to the landfill. A little bit went to the incinerator. And when we started diving into it deeper, what we found was the metal. These great fasteners that hold these buildings together are really hard to get out and very labor intensive. So salvaging lumber was a real niche business. The barnwood folks were doing it, but real small quantities. And so I knew some folks in the robotics industry, started talking with Andrew, who I'd done some research with before on some other projects in construction. I said, hey, can we automate this? And he's like, absolutely. And he starts building a benchtop prototype. No, literally the size about of a bench top, about 3 feet long. And after about a month and a half of work, he had his web camera sitting on there, identifying nails in a 2x4 and a little kicker kicking those nails back out of it. And so he'd actually written the software to automate it. And we use that to recruit Alex to get him on board because we have more computer vision AI expertise. And then went and connected up with some venture capitalists that I'd worked with. And they're like, we'll do this. And it's a massive problem, right?
Right.
How often do you tackle a problem where people want to give you the raw material, right? Because demo contractors right now are paying a lot of money to haul that material, all that wood waste off their job sites, tipping fees.
Oh, yeah.
And so they're more than happy to give it to us.
Well, listen, I mean, it's 30% of most homes that are being built today, 30% of them end up in a dumpster. So when a consumer looks at their house,
Yeah.
they have to realize they may be paying $100,000, but 30,000 of it's going to be carted away in a trash can somewhere and sent to the landfill. Now, don't be out there quoting me on the exact numbers, everybody. I know how this can go real quick and south, but we get the general gist, right? It takes 30-yard dumpsters, several of them typically on a single-family home job site. So this is a really, really big deal on how you can reclaim and reuse the materials from the past.
Absolutely. And that's just, if you're building new, just think about if you started with an old falling down house on that job site, the first thing that shows up is an excavator and a bunch of dump trucks to haul all the wood away. And one of our big sources of material right now is really these old, early 1900s office buildings and warehouses that people are demolishing in the major metro areas to put in high rise to increase the densification. And it's just beautiful, large cross section material that we're finding from these buildings.
Well, right. That's reusable and can be reclaimed versus just thrown in a landfill. So let's talk about that. What is the environmental impact of salvage wood with, the urban machine?
Yeah, so the EPA did some great research for us. They estimated 37 million tons of clean dimensional lumber is thrown away every year, right? So that doesn't include the pallet wood. That's just, 2x4, 4x12, all your dimensionals heading to the landfill. We believe we can recover half of that. And that would be equivalent to taking about 4 million cars off the road every year in the United States in terms of CO2 reduction.
Say that one more time. How many cars?
4 million.
Wow.
So it's massive, right? If we can, essentially replace, billions of board feet of lumber, right? So we could essentially, cover about 15 billion board feet, which is about a quarter of what we harvest here in the United States every year from our forests.
That's just absolutely incredible. And we're going to show this machine. We got a couple videos. We're going to show some pictures and so forth that we're going to talk about here in a second. But this has a huge environmental impact out there. And so do you have any competitors in this realm that you know of?
So right now we just compete with about $1.5 million grinder. Most of the demo contractors and C&D facilities just shred it, turn it into alternative daily cover or cogen fuel plant.
Yeah.
And then burn it up. So really, that's our big competitor right now.
So just, I want to make it publicly known. I've already asked Eric for the distribution rights for all of Pennsylvania, but they're not ready to go there yet. So all of you out there that are watching, watch out for me. This is a big deal. So I think not only can builders and demolition contractors use this, salvage companies can use this, like you were talking about, that are trying to reclaim and reuse the lumber out there. So why don't we give a quick view of what this machine is, and maybe you can talk us through these couple videos as we do it. Sound good?
Yeah, absolutely.
Let's hop into it. All right. Sorry, I got to kill the sound, everybody, so I don't get flagged on YouTube. So walk us through. What are we looking at here?
Yeah, so this is our first full-size prototype. This is actually prototype number 3 that we built. It's about 40 feet long. It's got multiple end effectors in it. It's got a shuttle system for moving the wood through it. And keep in mind, we had to develop everything, right? Nobody's built process equipment for moving wood with nails sticking out of it. And what we did first was we said, a lot of these nails and screws and fasteners are sticking off the wood because it used to hold like drywall or sheet good to it. So why don't we just start scraping those off, just pulling off the low-hanging fruit, the ones that are exposed. Mm-hmm. And so that's what our rake technology does here. It's a pretty low-tech solution, and it's just designed to just go after any exposed fasteners on the wood. And then once those are pulled off, then we bring in the cameras. So you'll see that flash there, our depth sensing camera, taking pictures of it. We take those photos, we run it through our software, our AI algorithm, and then it sends the end effectors after it. So that software is actually determining the type of fastener. Is it a nail, a screw, or a staple? And then assigning it to which end effector to go pull it out. And these end effectors, they do about 1,000 pounds of pull force. We can pull a bent over 16 penny nail straight out of the wood. So
Wow.
the goal is to remove all the fasteners with it. And so this end effector is pretty cool. We'll do staples, little tiny force, and then screws, we spin backwards. So we'll grab those heads and we'll spin them out because we can't yank on the screws, otherwise they shear off, and then we have a bigger problem.
Yeah. So how do you get a hold of those screw heads if they're down below the wood line, the top of the wood?
Yeah, so if anything's too buried, even like a nail or anything, say it's half of an inch down in, we'll actually slice that section of wood out. We'll skip it all together and just cut it out and then finger joint the material later.
Got it.
Or one of our partners can do that. And so really the nice thing is we're taking this technology and we're going to make it portable so we go to the job site. And what that does is it reduces a lot of that sheared fastener, because every time you handle the material with an excavator claw, it shears off more fasteners, causes damage. So by operating at the job site, we're increasing the quality of material, reducing our carbon footprint because we're not trucking this material all over. And then we can ship it directly from the job site to our customers. So less touch points.
Right, right. I love it. I love it. So if you're just joining us, everybody, we are on with CEO Eric Law of Urban Machine. We are talking about the first automated robotic with some AI machine that actually is going to help you reclaim, reuse, and recycle all the materials from your demo site right out of the wood, and then you can reuse that wood. So if you have any questions or comments, put them in the links. We'd love to hear from you. But otherwise, we are live on LinkedIn, YouTube, Facebook, Twitter, and Twitch. So get your tweets on. Tweeting's a hot thing these days, it looks like. Again, there's a lot of news out there on that stuff. But if you're not subscribed to our YouTube channel, you want to subscribe there. Over 10,000 hours watched every single month on our channel by the people that are making it happen, like Eric Law. All right, Eric, so tons of questions here. How when you're developing this machine and you add the science behind it and the scanning, the AI, walk us through that process. And, I know there's probably some IP that you can't mention, but if there's some stuff that you can share with us, how did that all come together? And can you share some of the biggest headaches of this whole process?
Yeah, so you've got two major components. You've got the hardware aspect, right? Those claws,
right?
Moving it, making sure we pull the nail and not shear the head off of it. And then you've got the software, right? How do we identify that nail, the location of it, its orientation, right? If the nail's bent over a 90-degree angle, that's a different approach than if it's straight through it. And so what our engineering team did is they said, Eric, we need lots of wood with lots of nails and fasteners. So I went out, reached out to a bunch of demo contractors I know, and they started saying, how many truckloads of this stuff do you want, right?
Right.
Big tall sides, 40-foot trailers started dumping in our shop, and we started bringing in lots of material until the engineer said, okay, we're done, we got lots, we're good. And then it was just scanning it, taking thousands of pictures of all the material to identify all those different fasteners to train our software. And the more data you put into it, the more training, the smarter it gets. And we did that probably for about 3 months of just scanning day in and day out. Our engineers just kept running more and more wood, and then you're tagging the fasteners and training it. What do they look like when the head is sheared off? What do they look like when they're bent over? To the point where the engineers are like, okay, we're good. And we started running it. And the cool thing about AI is as you feed it new wood, it still gets smarter. So the more wood we feed it, the smarter it gets. And so really it was just a volume game for our engineering team. Our software engineers who had never touched wood before, saws, never worked in a shop, are wearing boots out in a shop, hard hats, and warm fleece jackets last winter to run wood through this machine. And so it's been a lot of work there. And then on the hardware side, for Andrew and his hardware engineers, for them it's just hitting that sweet spot. Right? How do we work with that pick location with the software guys and grab it just correctly on all these different nail profiles and screw profiles and staples? And so they've done a phenomenal job. And, a lot of it's testing. We run a lot of these quick tests in our shop. How much force does it take to pull out a 16-penny nail versus a staple? What's that range look like? And then running shear tests on nails and different fasteners. So kudos to the team. We've got just super sharp. There are a bunch of real good researchers that go in, understand the problem, and then engineer solutions on it.
And when you say the AI learns, the more you feed it, the smarter it gets. What is it learning? Like, I mean, it's looking for nails, it's looking for metal, but like, how does it continue? How's it advancing itself?
Yeah, so the more fasteners you feed it, because obviously in construction over the last 100 years, we've used a lot of different fasteners, right? Every time a new building comes down, we see a new type of fastener come into the system. And so we got to train the software on that. We got to teach it. It says, hey, this is we've got these threaded screws. I forget the name of them, but they use it for MEP a lot of times, where it's got
Yep.
a straight head on it, but it's about 3/4 inch diameter head with a spiral body on it. And so those were taken down out of a 1960s warehouse. And so we had to train the software how to identify those and then how to remove them through it. And so as we build this database of all these different fasteners, the techniques to remove them, and then differentiating, a lot of times a rusty nail head looks a lot like a knot in a piece of wood. And so one of the things we had to do is add brushes to shiny up those nails so the machine knew it was a knot, or knew it as a nail and not a knot in the wood.
Wow. Okay.
So different pieces of wood have different characteristics, right? So as you introduce hardwoods, different species of woods not start to look differently. And what we want to do is we want to take this tech and not just identify the metal, but also identify wood species,
Right.
then go into grading the wood. Because if we can identify knots, we can identify knot dimensions, that's data that you use to grade material. And so then we can start to add structural ratings to the dimensional lumber running through our system.
So, all right, so take a step back here, right? So now you can add structural ratings to the lumber that's running through, so it can be reused right away on site, is what you're saying.
You got it.
And it'll detect whether it's rotten on the inside or right, all of those different things. I love the idea that you have to shine up the screw or the nail head and the learning side of this, because I would imagine when you first started this, you didn't know you had to shine them up for the machine to pick up on it. I bet it was like a scratch the head moment, right?
Why are they missing these nails
Right
at the board, or why does it keep hitting knots, right? Why is it digging into these knots? It's not a nail. And sure enough, they looked almost identical when you start looking at them.
Sure. And the idea, and now I understand the AI behind this, right? Because a nail from 1920 is much different than a nail from today. And it starts learning about what those nails are and then can decide how it's going to pull them or grab them. Is that basically it, right?
Yep. All right. And the orientation, right? Is it upside down? Is it missing the head? If you take the head off a nail, a lot of times it's hard to find which side is up and which side's down.
Right.
Same thing with a screw, right? If a screw loses its head, you got to figure out which is up and down to make sure you grab it correctly and pull it out versus pushing it further in.
So feeding the machine is manual, I'm assuming, correct?
We're actually working on automating that. So we do forklifts into the machine, and then there's a human interaction for what we call our big ugly fasteners right now.
Okay.
So think of like a big Simpson strong tie bracket or something, right? That's got 1/2 inch bolts holding it in. Those would be removed by the humans, and then they push it forward and it heads into the machine.
Got it. So, and as it's being fed, you have to, like, what if there's nails on every single side of it? Does it matter?
Doesn't matter. We clean all 4 sides. So the production unit will have those end effectors on all 4 sides running at the same time.
On all 4 sides at the same time. All right. So you threw me for a loop today, right? Because I didn't know about, the structural side of this and being able to certify or verify the wood and what its capabilities still are. That's absolutely amazing. So talk to us about where you're headed with this. What's the future looking like for getting these machines out to the general public?
Yeah, so our first machine will roll out in the shop at Q1 next year. So Q1 23, the first pair of trailers heads out into the field.
Okay.
And that's for field testing. So we've actually already started lining up client sites to go to and start cleaning material with those clients. And our goal there is really just to go from a shop environment to a field environment and look at our production rates, look at the challenges we have. Obviously, job sites, you go from a shop to a job site, it gets a lot dirtier. You got weather conditions and stuff like that. So we'll be stress testing all our electrical components and systems on it. Do our cameras survive bouncing up and down California's lovely roads here in the Bay Area.
Right.
And calibration and all that. And so this is the proof of concept. You'll see here we're at the in-feed from the forklift to a workstation. This is where the people will be set up with their tools, trim off any damaged ends.
So that's what you were talking about. If there's nails in it or it's damaged or there's a piece of metal inside of it, you just take that section out.
You got it. Yep.
And it looks like, is it made of aluminum?
This particular prototype is. So we
Uh-huh.
prototype a lot of stuff out of aluminum, and then usually production is out of steel.
Production's going to be out of steel. Got it.
Yep.
Got it. All right. So here's the feed. Those are the rakes you were talking about?
Yep, those are our custom rollers that we had to build. So this way there can be nails hanging about 3.5 inches out the bottom of those, and it rolls right past those rollers. Those fingers are freaking awesome in terms of moving material. And then there's the brushes on top for doing the polishing.
Right, right. And that way the machine can find the nails and then they pop the nails. Now, when the nails are dropped, where do they get dropped to?
Yeah, so that's one of the things we still have to build is essentially a cleaning mechanism.
Okay.
Blast them with air, and then they'll get dropped into bins on the bottom.
Right.
They'll go into scrap steel.
Into scrap steel. I love this. So those lights that are flashing apart the crosshair, is that helping them find the nails?
So that's the cameras going off. So
that's just the cameras going off. Okay.
Yeah, so they've actually got a light in them that they flash on it. And so they take a picture of the wood with that light. And the light, if you pause it, you'll notice there's a pattern in it. With that, it's pretty hard to see, but there's a pattern. There it is.
Yep.
It's that grid pattern from the light. And so these cameras, it's not just like a standard camera, but it actually senses depth. So it's depth perception on there as well. So that allows us to get the dimensions of the fasteners and the exact XYZ coordinates of them.
Yeah, very, very, very cool stuff here. So how big will this machine be, the field unit?
Yeah, so production will be 2 40-foot trailers. So it'll be 80 feet long in the field.
Yeah, 80 feet long in the field. Okay, so that's a pretty good size.
Yeah.
That's a pretty good size, but I would imagine as the technology gets better, it'd probably get smaller.
Yeah, we're hoping so. The big challenge is we got to be able to process material up to 30 feet long.
Yep.
When obviously residential, typically, 8 to 20 foot is most residential lengths.
Right.
Commercial, you go 20 to 30 foot for your joists and rafters. And the other thing we're processing too is you'll see here in this picture, this is a piece of furniture made out of glulam. There's a lot of engineered glulam coming out of buildings that were built back in the 80s.
Right.
That is a phenomenally high quality product, solid, straight material, and it's got a next life for it. And so that's what we're doing is processing solid lumber and then glulam as well.
So, okay. So how do you process the glulam? Just pulling the nails and everything just like you would on the other lumber. Got it.
Exactly. It's just heavier.
Just heavier.
Yep.
Mm-hmm. I think this is phenomenal. I love it. I love it. I love it. All right, let's get into the nuts and bolts. And we got a couple comments we're going to get to here real quick as well, so we might as well do that. Henry Mickelberg says it's hard to dislike this. Are you able to reclassify the structural strength C16, 24, etc. after you've done your thing?
Yeah, that's what we're working on. So there's a couple pieces that go into it. There's the visual grading capability, which we have with the cameras. And then we're also doing some tests around mechanical grading, right? Can we apply pressure, measure the distance of deflection for that piece of material, and then, knowing the pressure, determine what the structural integrity is with the mechanical grading. So we've actually got some researchers we're working with that are helping us out on this in terms of how do we regrade the lumber and how do we regrade glulam as well for the structural characteristics.
Wow. Okay. Awesome. Great question, Henry. Good to see you. I hope all is well with you. There was another question as well. What about recycling the metal that's coming out of this machine?
Yeah, absolutely. A lot of people ask us, can we reuse those nails?
Oh, yeah. Can you straighten them all out and make them shiny and like new again? So the customer's happy. Everybody's happy.
Those things are so smashed up typically when we get them from the demo contractors. I mean, like, you should see these things. They're wrapped around the 2x4 and curled and knurled. So unfortunately, that's got to be melted down unless somebody's got an art project coming up.
Right. Right.
The thing that would be interesting is the bolts. We see a lot of structural bolts, especially on the coast in earthquake country.
Right.
We use these big structural fasteners. So that's one area we're interested in because they don't tend to be deformed. They tend to come out pretty easy, the nuts and bolts and the earthquake fasteners. So that'll be interesting to see if we can snag those, scan them in some shape or form, and then bring them back into the market.
Yeah. It makes a lot of sense, right? If you could do that, for sure. All right, appreciate that. Jennifer made another comment. Did you say it's equivalent of taking 4 million cars off the road? And what she means by this is that's what the machines are going to be able to help recycle and reclaim would be the same as removing 4 million cars off the road.
Yeah, so if you take a look at lumber, salvage lumber uses, or reclaimed lumber is about 90% less energy than virgin lumber. The main differentiator is virgin lumber. You have to dry it, right? So you got massive kilns, typically gas fired, huge CO2 footprint with virgin lumber, and then it's got to be trucked, right? Most of the lumber comes out of Canada, Oregon, Washington, or out of the Southeast, and it gets trucked to the rest of the country. It's a huge carbon footprint. So when you compare that with using salvage lumber, ours is dry. I mean, our material is incredibly dry and straight because it's been sitting in a building held in place for 40 to 80 years. And then it's locally sourced. We're sourcing out of metropolitan areas, so we're not hauling it across the country. We're selling it directly back in those metros. And so when you look at that delta there on the carbon footprint from virgin to reclaimed, and then you look at the volumes, yeah, 4 million cars equivalent in terms of CO2 reduction on an annual basis is what our target is.
Yeah, and imagine if there was thousands of these across the country or around the world, right? I mean, I'm sure the goal is to get this out and have people use it for sure. Love it, love it, love it. Mark Willie's join us. What's up, Mark? I saw you put a lot of comments out there. Willie is on our BS Friday show as one of our hosts, so it's always good to see Mark. If anybody loves recycle and reclaimed anything, it is the long-bearded Mark. We call him Mark Bare Naked Willie, but he's not naked, just so you know. But he's big into passive house and energy efficiency. Good to see you, Mark. I hope you are well today, my friend. Michael Bruce from the Gulf Shores as well in Alabama. Always good to see you as well, Michael. And of course, you guys know Jory. Jory's behind the scenes today. Teamwork makes the dream work. Eric Lall, it's clear that you and your engineering team work well together. You've created a terrific solution for wood waste in a little bit of time. Yeah, you did. I mean, you definitely have done all of that. All right, so let's talk a little bit further into, who is the target market coming out of the gate. Like, I know you touched a little bit on it, but let's talk about timelines. How do people get a hold of this? I mean, everybody's going to want it, and how do they do it, and how affordable will it be?
Yeah, so coming out of the gate, so our first unit heads to the field in Q1. We'll build a second system in Q3 next year. So we'll have two running around Northern California by the end of next year. We'll be operating them ourselves, so they're not for sale yet. We want to get all the kinks and bugs worked out of them, get them really streamlined and efficient. And then we're going to go build about a dozen of them in 24, 25. That'll take off, and we'll spread those around the country in some major metro areas. Our customers that we source material from is the demo contractors, right? Those that are taking down the buildings. That's the number one source of material for us. We're also talking with some other folks that have large volumes of wood waste that want to process it there. Some of the C&D facilities. And then on the buy side, the material, anybody can buy it, right? That's the cool part, is any contractor can, I wouldn't hand frame with it. Wood's a little bit harder than virgin. But if you got a prefab home unit, if you want to buy it by the truckload, we're working with furniture designers, we're working with architects. Because the cool thing about this product is it's got a story. We're actually going to tag the material with a QR code, and so you can actually track the story of where that wood came from. Right? You can't do that with concrete and steel once they're ground up and melted. But wood, we can actually tag it, and we can say, hey, this was the building that was torn down here. Here's the cleaning process it went through, and then here's some info on the new building that it goes into. And then somebody can walk by it and hit it with their phone at some point in time. And so you get the warmth of wood, you get the story of wood, and then you get the environmental benefits. So just all around, it's a great product. And so that's why we're working with a lot of designers and architects and building owners to specify reclaimed lumber in their projects. And then when they're taking down buildings, specify deconstruction that helps maximize the volume of material we can reclaim compared to traditional demolition.
Oh, man. All right. So you left out the part about labeling all the wood so we know where it came from and how it's already been reused. I mean, it's kind of like clipping the tails of lobster, so you know which one, has does eggs and doesn't do eggs and all that stuff. So that's pretty awesome. So let's talk about the impact of this. Your website shows the revenue stream this could create for demolition contractors, which is really clear. But let's think a minute about distressed communities, especially here in the United States and around the world, urban locations, locations that have been abandoned or in need of being rebuilt. Detroit would be a good example of that. I mean, this is a game changer for those locations where there are tens of thousands of homes that need to come down in the community. So diverting the waste to provide usable building materials, because the metal can be recycled. I mean, the big cities should be ringing your phone off the hook.
You got it. That's our target. Those big metropolitan areas that have lots of wood building stock, Detroit to New York to LA, everybody's built with wood for the last 100 years. And those buildings, as long as they're structurally intact, right? As long as the termites haven't gotten to them and the rot
Yeah.
hasn't, well, as long as they're structurally intact, are great sources for material, and then it's locally available, right? You
Right.
clean it up, we clean it up, and then feed it right back into the building ecosystem. So for those communities, it's a huge economic win and environmental win for them.
Yeah, I think it's great. So how about this? Like, who would be the target person? A community goes in, they pull all this metal and lumber. Who owns that, right? Like, you think about these big communities like you're talking about. Is that something that the city gets to reclaim? Like, how do you see the business model of that working, or haven't you got that far?
Yeah, so it kind of depends on who owns that property and who owns those buildings.
Right.
So if the city's, condemning a bunch of buildings and they're going to go take down blocks under blight, then we can work with the city, right? The city will probably have us work with their contracted demo contractor on the sourcing and the process. And then the city can say, hey, we want the material back, or sell it to our lumber yard and they'll cut it, rip it into the length they need, or here's a prefab manufacturer, right? The nice part is once it's metal free, you can use it anywhere in the lumber ecosystem, right? Because it's already cross-sectionally cut,
Right.
it's stable, it's clean, so they can rip it, mill it, plane it, whatever they want to do with it at a standard mill, and turn it into the product the contractors need in that new construction.
What am I missing?
What are you missing?
Yeah, I mean, listen. So we have a machine that's going to reclaim the lumber from the demolition site, right? It's going to clean, it's going to scan it, it's going to clean it up, it's going to pull the metal out, it's going to cut out all the bad parts. It's then going to let you know whether it's what the engineering is left on, or the structural integrity of the wood. So now you know where you can reuse it on site, and it's tagging it with RF codes or whatever it's going to be, so we know where that lumber came from in the future. What are you not telling me, Eric?
All we got to do is get people to update their specs and say, I just want a spec reclaimed instead of virgin. We need the designers out there. We're going to need the building officials out there. So some building codes have already changed. State of Washington has already updated theirs for reclaimed lumber.
Okay.
We need all the folks to do that. And then, educate your contractors and stop sending it to the landfill. That's probably going to be one of the biggest ones, especially on the residential side.
Right.
We've all seen the excavator shows up, the line of dump trucks shows up, and they just smash the heck out of it and turn it into it. That's not going to work. And so what we need those demo contractors and those municipalities to, hey, we don't accept it. We're not going to fill our landfills anymore. You got to take these houses apart, because not just the wood is valuable, but there's a lot of other material. You're seeing a lot of deconstruction contractors show up out there, a lot of salvage folks go. And not just on the residential side, but the big commercial side.
Right.
Just imagine we saw a 600,000 square foot office building just get destroyed in about 4 days by excavators. That's a lot of material going to a landfill, right? And so everybody's getting kind of a memo that says, okay, we can't do this anymore. It's too expensive. There's too much value in that material. Let's start earlier. And it really doesn't delay your schedule. You just have to think about it ahead of time, right? If you do the work like everything else in construction and put the time in up front, update your specs, update your drawings, tell everybody what we're doing, not going to be an impact on your schedule.
Yeah, I love it. So we had some conversations recently with some pretty big economists and investment bankers, one of which, Margaret Whelan, who's out there. And we were talking about, is our housing crisis a labor issue? Is it a cost issue? Or is it a waste of material issue? When you're throwing 30% or the numbers you're even talking about away on pretty much every project out there, if we can reuse all of that lumber, because now it's really free to whoever's taking it down, or if they're going to resell it, like say to a general contractor, it's used now, so it should be less than new stuff, I would imagine. But old wood is actually stronger, so I'm sure Mark's going to light me up in the comments there. But there's a real case to be made of how this can help turn around the housing crisis that's happening out there as well.
Absolutely. We were talking with one of the major waste companies here in the United States, and they did a study, and I think I'll be off on the exact number, but I think it's about $14 billion a year worth of valuable material goes into their landfills.
Yeah.
It's just eye-popping, the numbers. And so we look at wood, but there's a lot of other great materials going that route. And it's just because, people found a way to do this. It was cheaper, 50 years ago, and they haven't changed.
Right.
Today, it's obviously not cheaper. If you thought permitting a house was expensive, imagine trying to permit a landfill.
Yeah, right.
Yeah.
Yeah, for sure. I would, right, imagine. Hey, we got Buzz in the house. He says, keep on bringing the good stuff, Eric. So that's always good. Good to see you, Buzz. I hope you're staying warm up there in the north. Love it, love it, love it. Look at this. I don't know who this LinkedIn user is here. I'll have to go to LinkedIn and look, but what a great technology. So maybe, Jen, you can tell me who that is. I think she just popped it. Chris Rouse. Hey, Chris. Good to see you. Thanks for tuning in today, Chris. Appreciate the comments and everybody else that's doing it. All right, LinkedIn, you're joining late, but do you envision that this technology is best brought to the job site or reclaimed wood brought to a processing facility?
Yeah, so for the bigger buildings, the job sites, right? We'll have the big laydown areas, build do it there at a big commercial office building, warehouse, no problem. When you start to look at residential, if somebody's remodeling a house, they're going to pull a couple thousand board feet out. It doesn't make sense for us to roll up 80 feet of equipment. And so that will end up at a central processing facility where our machines will be based.
Awesome. Appreciate the comment. Thank you so much. All right, look at this. I don't know if you know Steve Burrows, but everybody should know Steve Burrows. He's one of the guys that I say, he's like the Dos Equis commercial, one of the most interesting guys in the world, and I mean that wholeheartedly. Has his own IMAX movie as well. He says, what is the cost model relative to virgin lumber?
Yeah, so our goal is to compete with virgin lumber, even at their prices back down. Not like the COVID prices last year and type of thing, but our goal is to compete head-to-head with virgin lumber. Right now, today, we're there on the larger cross sections. Run like a 4x12, 4x16 through our system, where the virgin price is, $1.25, somewhere around there today. And then our goal is to keep driving down our prices, increasing our throughput. So eventually we can compete with the 2x4 price, which is probably about 45 cents a board foot or somewhere around there today. And that's our goal, is to compete head to head with virgin lumber.
Compete head to head with virgin lumber. That's awesome. Well, listen, I mean, I don't know what else you're keeping from me or not telling me about this machine, but so far it has done everything but pour me a drink and make my dinner.
That it definitely does not do.
Yeah. So how do people get started with you, whether it's a city, government, or an individual company out there that's interested in this product? Where are you with it? When can people expect actually to be able to see some of these in the field?
Yeah, so you'll start to see, we'll do some videos here in Q1 with the first machine running around here in Northern California. We're booking job sites for it now for Q1, Q2 next year. So reach out to us if you're here in NorCal. If you're not, we had somebody from Australia reach out to us a couple days ago. We're going to chat with you, talk to you about your needs and what you're looking for, and then put you on our list. So as we start to expand, we want to get machines out to you as quick as possible. Obviously, this technology takes time. We don't want to release a machine full of bugs and that's still in a beta phase. It's
right.
Construction reliable, right? So much so that one of the big rental companies can maintain it for you.
Sure.
So we're probably about 2 years away from that. But in the meantime, we love to talk to people with project specifications. Let's talk about reclaiming lumber, because a lot of the architects we talk to today, their projects won't hit construction for 2 to 4 years, right? Even on a house these days, right? If you're designing a house today, it may not start construction for another 12 to 24 months.
Right.
The supply chain and the way everything moves so slowly these days. So let's have a conversation. Let's talk to you about getting your specs updated and getting those contract documents. So it talks about reclaiming and salvage. And then we'll come visit you here in a couple of years and help you clean that wood.
I love it. I love it. Well, I'm 100% sure that we're going to see you in a neighborhood near us very, very soon. I think that's super, super big. So listen, Eric, unless I have missed something, thank you so much for coming on the show today.
Absolutely. It's been a pleasure, Dave. Thank you very much for having me.
Yeah, it's been awesome. So, all right, everybody, listen, BS Friday with my good friend Mark Bare Naked Willie coming up 1 p.m. this Friday. We got Connor Malloy on the show. And if you don't know Connor, you need to know Connor. He's a passive house instructor. He's a professor at George Brown College, and he's here to discuss building science with my good friend Mark Bare Naked Willie, who's in the comments today as well. If you want to get to know him, click on some of his links. So, all right, everybody, that's a wrap for today. I appreciate everything that you're doing, Eric. I look forward to helping you launch this. And when I mean helping you launch it, getting the word out, this is a big deal. And we appreciate you taking the time to be on our show to help do that.
Awesome. Thank you very much, Dave.
Yeah, very, very welcome. All right, everybody, that's a wrap. Thanks for watching today. Thanks for commenting today. Eric, you stay right there. I'll come back to you after the show. But everybody else, it's Wednesday. There's still 2 more days after today to build it better. Let's not take the brakes off. We are going to change how we build. We're going to change the carbon footprint, and we are going to make our homes healthier and safer for the next generation. I'm Dave Cooper. We'll see you next time. Bye now.